CATT-NW Season 1, Episode 12. Intro to Digital Math Considerations for Screenreader and Braille Access.
CATT, Center for Assistive Technology Training Northwest.
Good morning, everybody, and welcome to Tech in 20. We are welcoming Allison Mello this week, who is an assistive technology specialist from the California School for the Blind. Allison has prepared an introduction to digital math considerations for Screenreader and Braille Access. Thank you so much, Allison, for coming to hang out with us today to share your expertise, and I'm turning the floor over to you.
Hi everyone. Thank you guys for joining this morning. I have a little demo and sort of a Q&A all about an introduction to digital math and how it works and responds to your screen readers and Braille displays and Braille note taker technology. I'm going to begin by doing a small demo. Bear with me as I share my screen.
Sharing meeting controls. Share preview WMD. Screen sharing meeting controls. You have started screen share. Press.
Okay. And so I'm going to
Task switching. Introduction to accessible math demo dashboard.
take us over
Page 2. Edit. Page
to
2.
my Microsoft Word document. And so hopefully you can hear my JAWS because that will become very important. So I put together a little document, a Word document of different experiences that our students have and face with math content in the classroom. So I'm going to let you hear them. We're going to talk about them, and then you'll hear them again.
Equation left parent 1 right page 1. Blank. Top of file. Picture 1 image. Blank. Picture 1 image.
So this said picture 1 image. And this is a great example of when our teachers, paras, or even us TVIs are able to snap a quick shot of the board that has some math content on it in a classroom, and then we're able to put that picture in a Word document or any kind of word processing program. Now, the problem is we get absolutely no information from this image if you're a screen reader or Braille user. I just hear that there's a picture, and my Braille display will just say picture 1.
Picture 1 image. Picture 1 image. Blank.
The next one we have here.
An image of 3 equations drawn on the chalkboard image.
So this one did have an alt description. And it said that there were 3 equations in this image, and that's fabulous. I now know that there are equations on this image, so at least I know that it's math content. But again, I don't know what those equations are. And I'm going to slow down my JAWS real quick.
The host has spotlighted your video for everyone.
Give me 1 second. I don't remember how to do this really quickly.
Alt-Control Windows page down.
Oh my goodness, thank you.
Also, Alt-Windows S will turn off your alerts, but you have to do it before you do your screen share. Sorry, I'm a tech.
Okay, Alt-Windows Control page down, you mentioned?
Correct.
Slower.
Okay, thank you. Okay, so we are going to listen to this image again.
Blank. Picture 1 image. Blank. An image of 3 equations drawn on the chalkboard image.
So again, that's the image of 3 equations drawn on the chalkboard. Good to know.
Michael Tuttle put in
but it has not told me what is actually in the equations.
Blank.
Next.
Page 2. Equation left parent 1 right parent is quote 2x plus 7 equals 19. Quote equation left parent 2 right parent is quote 4 left parent y dash 3 right parent equals 20. Quote image. Michael Tuttle has left.
So again, this is an image, and we
Michael
heard some
Tuttle.
math there. Jaws did say some math. That is great. And it is in the alt tag. Awesome. But the screen reader isn't actually reading math content. It is reading a alt description that somebody put in with this image. And when I have my Braille display, I do not
Ian
see
McMeekin.
math. I see the actual
McMeekin.
words that
Ian McMeekin.
are going with this alt description. So I still do not have access to the math content that is in this alt tag.
Ian
Not
McMeekin.
to mention, because the alt description
Ian
has
McMeekin.
been added to the photo, I still can't actually navigate using traditional arrow navigation that a screen reader uses to read by word or by character, or in math terms by expression or by individual symbol, number, or letter. I still cannot do that with my arrows in terms of this alt description that has the math. Every time I hear the math, I will have to memorize it. So I'm going to press the right and left arrow and let you see what I mean.
Blank. Equation left parent 1 right parent is quote 2x plus 7 equals 19 period. Quote equation left parent 2 right page 1.
Pressing
Blank.
the left arrow.
Page 2. Equation left parent 1 right parent is
Pressing
quote
the
2x
right
plus 7
arrow.
equals 19 period. Quote.
So every time I hear the exact whole thing, I can't explore this equation on a granular sense.
Blank. 6x-2y equals 45. Blank. 6x-2y equals 45.
This math content has not been created using the Microsoft Word equation editor or any type of equation editor. It has simply just been written using my keyboard. I wrote it. I wrote 6x
6x-2y equals 45.
dash 2y equals 45. Now, this is almost there. Almost. But the problem is, because this is not being acknowledged by my screen reader as actual math content, again, the Braille display will not show it in Nemeth, and I will not be able to interact with it in the same way that I would be able to if I was using Nemeth Math to write my answer, or UEB Math to write my answer, because this has not been properly identified as math content by my screen reader.
Blank.
The last one,
Math content 2x plus 7 equals 19.
I have 2x plus 7 equals 19. But if anybody was listening, I'm going to do it one more time.
Blank. Math content 2x plus 7 equals 19.
Even going to go slower.
Slower. Slower. Blank. Math content 2x plus 7 equals 19.
Math content. So here we actually have something that has been picked up by my screen reader as accessible math content. So it will not only read the symbols as they're intended to be read, so using subtraction and multiplication signs in their proper way that it is read in math, not just like an X or a dash for minus. So it is being read correctly, and my Braille display would then show the correct way that I can choose Nemeth or UEB Math. You would select that in your JAWS settings, and it would put the output as either Nemeth or UEB Math, and I could explore it tactily via my Braille display, and I can explore this math content on a granular level using JAWS, and I'm going to press the right.
Blank. Equation comma math content. X math content 2. X plus 7 equals 1, 9.
So I can explore it on a granular sense. I don't have to memorize the equation, and the screen reader knows that it's math content, and the Braille display knows that it's math content. My output is the correct math code for my learning, and I'm able to have access to this math. That's the end of my demo.
Task switching. Screen sharing meeting controls. To move to an item, press the arrow.
Now, Ting is going to share, and I have a few quick slides that we're going to talk about.
And I'm just getting the slide deck up right now. Give me one sec. Okay, come on,
And
Zoom.
thank you for bearing with me with all of the JAWS announcements.
Okay, Allison, I'm sharing the screen now and making this slideshow. Has everybody seen the slideshow? I think. Okay. All right.
We can just go straight to slide 2. So our first slide is what is accessible to a screen reader and Braille display. And so we kind of just saw that. Pictures without alt tags are not accessible. Pictures with alt tags may provide some information, but unless the alt tag has been written correctly, it may provide none. And also it requires a user to memorize what is being said, and there is no translation to Nemeth math or UEB math based on an alt tag on your Braille display. And you can read and write Nemeth math and UEB math using the JAWS Math Viewer and the JAWS Math Editor. Content that has been written in specific math markup languages, we'll talk about in a second, that content is the content that is accessible to our Braille and screen reader users. So we'll go to the next slide. Why do TVIs need to know about math markup languages? Well, TVIs provide access or lead our gen ed teachers towards access. They need to have some understanding of what is accessible and why, and what is not accessible and why not, so that they can help guide that teacher and student and IEP team towards tools and strategies and workflows that are accessible for accessing math. We'll go to the next slide. So what is Math ML? So math markup language is used to create accessible digital math content. It is a markup language used on the internet, so in web browsers, to make math symbols and math numbers and integers and expressions and letters become accessible to the screen reader such that it is read in a manner that makes sense for that type of mathematical operation. So it would read an X, which can be used as a multiplication symbol, as a multiplication like 6 times 4 and not just 6x4. So that's what Math ML does. So the CSB just came out, doing my own little plug here. So CSB on our screen reader training website, we just added a special edition module for the Math ML Builder. And so this lets you input numbers into various operations, fractions, multiplication symbols, and you can play around with it and see what the actual math markup language looks like and what the end product looks like for your screen reader user. And you can hear how it identifies the expression or equation as math content, and you can use the JAWS Math Viewer and Math Viewer to kind of explore it on a more granular level. So that's on our SRT. Okay, next slide. So what is LaTeX? So we just briefly brushed on the fact that Math ML is a markup language used to create accessible math on the internet and web browsers, but LaTeX is also a typesetting language. So it's something that people use. It's shorthand. It's an abbreviated way to write MathML. It typically is used by higher level math in college and in higher level college science classes. So it's a shorthand. So if you look at a MathML, like for example on CSB's SRT MathML Builder, you'll notice there are a lot of tags to write a very simple equation. A lot of coding goes into writing a simple equation, but the LaTeX is what an actual person might use to write out. So it's simple. And still, LaTeX, this typesetting code, you can kind of think of it almost as like a font. It still needs to be displayed by an equation editor to become that actual end product math content that we just saw in my Microsoft Word document. Next slide. Is MathML what I'm using in Microsoft Word? Well, that's a very good question, especially since I just showed you accessible math content in a Microsoft Word document. The simple answer is sort of. So Microsoft Word did this really lovely thing, and they made their equation editor, which is accessible natively in Microsoft Word. It's accessible to Screenreader users, teachers, and essentially what it does is it takes MathML and drops it into this very user-friendly interface, so you never have to learn that coding language, but you can still create accessible math content. I also slipped in a really great tutorial that I have bookmarks for using the Microsoft Word equation editor. And this particular resource talks about how screen readers can use it, and LaTeX or shorthand for these codes is described in there. And it has a lot of different examples of how you can use the equation editor. So it's a really great resource if you are new to Microsoft Word's equation editor. Next slide.
And just a quick time check, Allison, we probably only have time for maybe one or two more question answer things.
Sounds great. I got you. Thank you. So the difference between MathML and LaTeX, we kind of talked about it. One is the big language that writes accessible code for math content on the web, and the other one is the shorthand that a person might use. The best question here, number 7, do I need to know math markup languages to create accessible math content? Absolutely not. You have lots of different tools like the Microsoft Word editor, MathPix, Equatio, MathType, all of it does use these languages to create accessible math content. And then the next one, and probably our last question today, is do my students need to know it? And it becomes student dependent. Some students will just do their math classes using that Nemeth and their Braille display, and not need to know these math markup languages. But you will have that very exceptional student who might go into higher math and science classes in the future at college, and these, especially LaTeX, will become helpful in keeping up and producing accessible math content that they can turn in on their own. I know
Fabulous.
Thank you.
I think that is actually the perfect stopping point. We can leave people at the edge of their seats. And just a reminder that this Q&A document that Allison put together, it's linked from our training schedule, and the link to the training schedule is in our chat as well. So far, for some of you who have been following the series from the beginning, we did 10 weeks on Desmos. We're clearly now switching gears and moving into how to prepare accessible math. So Allison, leaving us hanging on this question of, do teachers need to know these math markup languages? We are definitely going to continue picking up on this thread. We are going to be taking a break from our Tech in 20 series for the next 2 weeks, and we will resume in 2 weeks. So thank you so much, Allison, for this presentation. We hope we could have you back to finish out the rest of the questions that you had prepared for us. But this was such a great introduction to just the digital math considerations for Screenreader and Braille access. And I know many of us TVIs, including myself, have always wondered these things when it comes to math. So thank you again.
Thank you.
CATT, Center for Assistive Technology Training Northwest.
The contents of this video were developed through a partnership with the American Printing House of the Blind, APH. CATT Northwest is based at the Washington State School for the Blind, WSSB. Logos, WSSB and APH. The contents of this video were developed under a contract authorized by the Department of Education. However, these contents do not necessarily represent the policy of the Department of Education, and you should not assume endorsement by the federal government.